Next, we have the fundamental theorem of algebra. If p of x, so if a polynomial is of the nth degree, then p of x has exactly n roots. So this was developed by Gauss when he was 22 years old, so not that much older than you are. And what that says is if a polynomial is of the 5th degree, it will have 5 roots. So looking back at what we did in the last segment, we had this x to the 4th. You see this has a degree of 4, highest exponent. And when we finished, we had 1, 2, 3, 4 roots. All right, so remember to determine the degree of a polynomial, you look for the highest exponent of x. So example 2, how many roots do each of the following polynomials have? Well, we look at this one and we see that the degree is 7, so the number of roots will be 7. B, if I take a look at this one, you see I tricked you a little bit, it's out of order. The highest degree right there is 3, so it has a degree of 3, which means I have 3 roots. So then you give a try at that one and see how you do next class. Example 3. How many roots does the following polynomial have and what are they? Well, we can answer the first part of that pretty easily. We see that it's got an exponent of 3, so we know that there's going to be 3 roots. And if you think back, we actually know how to factor this. You may not remember it, but you should remember how to start it. These are both cubes. So my first step on this is going to be to do x minus 5, cube root of this, same sign. So you should be able to come up with that first root. And then you may remember how the next one goes, where it's the first one squared, so x squared, then opposite sign, multiply 5x, and then plus 25. If you didn't remember how to do that, the nice thing now is with the synthetic division, we can divide and find the other one. So let me just do that. So I'm going to do 5, and I'm going to divide it into this. So I've got a 1. Oops, I'm missing an x squared, so there's a 0, an x, and then minus 125. And then when I come down and do this, this gives me 1, 5, 5, 25, 25, 125, and 0. And there you see my x squared plus 5x plus 25. So if you don't remember this, now you can figure it out. To find my other 2 roots now, I'm going to have to use the quadratic formula and do negative b plus or minus the square root of b squared. So 25 minus 4 times a times c. So 4 times 1 times 25 is 100 divided by 2. So I'm using this with my quadratic formula. So that's going to be negative 5 plus or minus the square root of negative 75 over 2. Simplify that, negative 5 plus or minus, this is 25 times 3. So 5i, because of the negative, radical 3 over 2. So I end up with 3 roots. I have the root, see if we get this up here. I have the original root 5 from here. And then I have negative 5 plus 5i radical 3 over 2 and negative 5 minus 5i radical 3 over 2. So then that's going to lead us to the conjugate root theorem. If a polynomial with real coefficients has a plus bi as a root, then a minus bi is also a root. So if you think about it, whenever we have to use the quadratic formula, we have the plus or minus. And if it's going to be imaginary, then we're going to have the plus, the 5i, and the minus, the 5i. We're always going to have a plus version and a minus version. So that's the conjugate root theorem. So it says a polynomial has solutions or roots of negative 5, 4i, and 1 minus 3i with no multiplicities. Oops, with no multiplicities. What are the other roots? Well, negative 5, that's real, so that doesn't have a partner. But for I imaginary, it's going to have its conjugate, which is negative 4i. And 1 minus 3i, again, is imaginary, so it's going to have its conjugate of 1 plus 3i. So the degree of the polynomial is going to be 1, 2, 3, 4, 5. So 5 there. So you try this next one. So we'll stop and pick up example 5 on the next video.